We're going to talk through lesson 94 today to help you work through those problems. These are uniform motion problems. This is our second lesson on uniform motion problems. Remember, this uniform motion just means that we're assuming that there's some similarities in the problem, in the distance problem. We also use the distance formula to solve motion problems. Distance equals rate times time. Now I'm going to work through example 94.2 with you. Remember, we're going to set up equations that we will then use substitution or elimination to solve. So in example 94.2 on page 392, we see that a train starts from Toledo at 11 a.m. and heads for Mackinac, which is 332 kilometers away. At the same time, a train leaves Mackinac and heads for Toledo at 65 miles per hour. If the trains meet at 1 p.m., what is the rate of the first train? So we see to begin with that the train leaving from Toledo, so this is the time that it takes them to travel, leaves at 11 a.m. and it meets at 1 p.m. So that's 2 hours. We also see that at the same time, a train leaves Mackinac and heads to Toledo, and it meets also at 1 p.m. So the time for the train that leaves Mackinac is also 2 hours. We know that the distance of both of these is going to equal 332 miles. The distance that each train is traveling is the same. We also know that the rate for the train that leaves Mackinac is 65 miles per hour, kilometers per hour. We do not know the rate of the train that leaves Toledo. I believe that's what we're going to be looking for. Now, we know from this equation that the distance for the train that left Toledo plus the distance for the train that left Mackinac are going to equal the 332 miles because they're traveling the same route, but they're meeting each other. So together, they're going to accomplish that whole route. Now, I can always replace distance with rate times time. So I'm going to take the distance for my train that left Toledo, and I'm going to replace that with time and rate for Toledo plus time and rate for Mackinac. And those are still going to equal 332. We've just replaced D with time times rate right there. Now we can go in and substitute. We don't know RT, so that stays. We know that TM is 2 and that RM is 65. And then we have an equation that we can solve. And if we solve this equation correctly, we should end up with the rate that our train, that first train that leaves Toledo travels at, would be 101 kilometers per hour. These problems can be a little bit confusing. Start with what you're given. Label what you're given. Remember that distance equals rate times time, and we can replace distance with the rate times time at any point, and then use substitution and elimination to solve. Thanks.